The moon, our closest celestial neighbor, has captivated humanity for millennia. Its silvery glow and ever-changing phases have inspired countless myths and scientific inquiries. But the moon is far more than just a beautiful object in the sky. It is a world with a rich and complex history waiting to be unraveled. The moon's surface is a testament to its tumultuous past. These landscapes hold clues to the early solar system and the origins of life. The moon's surface is a tapestry woven with craters of all shapes and sizes. These craters are not merely blemishes on the lunar landscape but rather indelible marks left by a violent and chaotic past. Each crater tells a story, a tale of cosmic collisions that shaped the moon we see today. These celestial scars are formed when asteroids, comets, and other space debris collide with the lunar surface. The impact releases a tremendous amount of energy, excavating vast amounts of material and leaving behind a crater. The size and shape of the crater depend on the size, speed, and angle of the impactor. Some craters are small, mere indentations on the lunar surface. Others are colossal, stretching hundreds of kilometers across the moon's face. The South Pole-Aitken Basin, one of the largest known impact craters in the solar system, is a testament to the immense forces that shaped the moon billions of years ago. Nestled near the moon's south pole lies a feature so vast it dwarfs all others, the South Pole-Aitken Basin. This colossal impact crater, spanning an incredible 2,500 kilometers in diameter and plunging 13 kilometers deep, is a testament to the catastrophic events that unfolded in the early solar system. Imagine standing on the rim of this immense crater. You would gaze out over a desolate landscape, a sprawling vista of shattered rock and shadowed plains. The basin's sheer size is difficult to comprehend, its rim a distant horizon curving away in all directions. The South Pole-Aitken Basin is not just a scar on the moon's face, it is a window into the moon's deep past. The impact that created this basin excavated material from the lunar mantle, the layer beneath the moon's crust, scattering it across the lunar surface. This material offers scientists a glimpse into the moon's interior, providing valuable clues about its formation and evolution. The South Pole-Aitken Basin holds many secrets, hidden within its vast expanse and shrouded in perpetual shadow. One of the most intriguing mysteries lies in the basin's permanently shadowed regions, areas where sunlight never reaches. These regions, some of the coldest places in the solar system, are thought to harbor water ice, a precious resource for future lunar exploration. The presence of water ice in the Aitken Basin has profound implications. It suggests that the moon, once thought to be a dry and barren world, may hold vast reserves of this vital resource. Water ice could be used to sustain future lunar outposts, providing drinking water, oxygen, and even rocket fuel. Scientists are eager to explore these shadowed regions, to unlock the secrets they hold, and to determine the extent of the moon's water ice reserves. The South Pole-Aitken Basin, once a symbol of the moon's violent past, may hold the key to a sustainable future on our celestial neighbor. Section 5. Theophilus, a crater with a story. While the South Pole-Aitken Basin dominates the lunar landscape, Theophilus crater, located near the moon's equator, offers a different perspective on impact cratering. This relatively young crater, estimated to be around 1 billion years old, is remarkably well preserved, its features still sharp and distinct. Theophilus is a complex crater, with a diameter of 100 kilometers and a depth of 4.2 kilometers. Unlike simple craters, which are bowl-shaped, complex craters have more intricate structures, often featuring central peaks, terraced walls, and multiple rings. Theophilus's central peak is particularly striking, rising nearly 2 kilometers above the crater floor. This peak, formed when the crater floor rebounded after the impact, is a testament to the immense forces unleashed during the crater's formation. Section 6. Central peaks, reaching for the stars. Central peaks are a common feature in larger impact craters. They form when the tremendous pressure of an impact causes the crater floor to rebound upwards, much like a drop of water splashing back up after falling into a pond. This rebound effect creates a central uplift, sometimes forming a single peak and sometimes a complex of peaks. These peaks are not merely aesthetic features, they offer valuable insights into the target material's properties. The height and shape of a central peak can tell scientists about the strength and composition of the material that was impacted. In the case of Theophilus, the prominent central peak suggests that the impact excavated material from deep beneath the lunar surface. By studying central peaks in craters like Theophilus, scientists can better understand the mechanics of impact cratering and the properties of the lunar crust. These insights are crucial for interpreting the moon's bombardment history and for planning future lunar missions. Section 7. Lunar Layers, Unveiling the Past. Impact craters like Theophilus are not just surface features, they are windows into the moon's interior. The impact that created Theophilus excavated material from deep beneath the lunar surface, exposing layers of rock that would otherwise be hidden from view. These exposed layers, like pages in a history book, tell the story of the moon's geological past. By studying the composition and arrangement of these layers, scientists can piece together the sequence of events that shaped the lunar surface over billions of years. Theophilus's terraced walls, formed by the collapse and slumping of the crater rim, provide further clues to the moon's internal structure. The spacing and arrangement of these terraces can reveal the mechanical properties of the lunar crust, helping scientists to understand how it responds to stress and deformation. Section 8. Lunar Exploration, a New Era. We are entering a new era of lunar exploration, driven by renewed scientific interest and the potential for future human presence on the moon. Missions like NASA's Artemis program aim to establish a sustainable presence on the lunar surface, paving the way for more ambitious endeavors, such as human missions to Mars. These missions will rely heavily on our understanding of the lunar environment, including its geology, resources, and potential hazards. The knowledge gained from studying features like the South Pole-Aitken Basin and Theophilus crater will be invaluable in selecting landing sites, extracting resources, and ensuring the safety of future lunar explorers. The moon is no longer a distant and unreachable destination, but rather a stepping stone to further exploration and discovery. As we venture back to the moon, we carry with us the knowledge gained from decades of scientific inquiry, ready to unlock the secrets that our celestial neighbor holds. Section 9. The Search for Water. Lunar ice and its importance. One of the most exciting prospects of lunar exploration is the search for water ice. The discovery of water ice on the moon has revolutionized our understanding of our celestial neighbor, transforming it from a seemingly barren wasteland into a potential resource frontier. Water ice is not only essential for human life, but it can also be broken down into its constituent elements, hydrogen and oxygen, which can be used as rocket propellant. This means that lunar water ice could potentially fuel future missions to Mars and beyond, making the moon a critical stepping stone in our exploration of the solar system. The permanently shadowed regions at the lunar poles, including those within the South Pole-Aitken Basin, are thought to be the most promising locations for finding significant deposits of water ice. These regions, shielded from the sun's rays, have remained incredibly cold for billions of years, allowing water ice to accumulate over time. Section 10. Future missions, returning to the moon. Several space agencies and private companies are planning missions to the moon in the coming years, with a particular focus on the lunar South Pole and its potential water ice resources. These missions will use a variety of instruments and techniques to map the distribution and abundance of water ice, as well as to study other aspects of the lunar environment. NASA's Volatiles Investigating Polar Exploration rover, Viper, is one such mission, scheduled to land near the moon's south pole in 2024. Viper will be the first rover to explore a permanently shadowed region on the moon, drilling into the lunar surface to search for water ice and other volatiles. These future missions will provide us with unprecedented insights into the moon's history, composition, and potential for supporting human life. They represent a new chapter in lunar exploration, one that promises to unlock the moon's secrets and pave the way for a sustainable human presence beyond Earth. The moon's enduring allure. The moon, our closest celestial neighbor, continues to captivate and inspire us. From its iconic phases to its cratered surface, the moon has played a profound role in human culture and scientific inquiry. Delving into the moon's mysteries, we appreciate its complexity and its importance in understanding our place in the cosmos. The South Pole-Aitken Basin and Theophilus crater offer unique windows into the moon's violent past and future exploration. As we embark on a new era of lunar exploration, we carry the knowledge from decades of scientific inquiry and the desire to explore the unknown.